Hi and welcome to the last section of Chapter 2, Section 2.7, Solving Modulus Functions. So, I'm going to go straight into two difficult questions and then set you some work at the end. So here's the first question. So please turn to question 6, page 52 of your Pure 2 textbooks. And I'm hoping you've all got your Pure 2 textbooks now. If anyone hasn't, please email me to sort that out for you because we've got a new order in. Okay, so it says that when m of x equals n of x has no real roots. Okay, so this is the key here, no real roots. Find the possible values for the constant k. So what we need to do here is sketch both of these, have a look what it looks like, and if there's no real solutions, what that means is that this line will not intersect this modulus curve. So no real roots means that these two, m and x and n and x, do not intersect. So the first thing we're going to do is sketch n of x. Now you have had a lesson on sketching modulus functions. So if I just write down n of x again. So you can pause the video, have a go at doing this yourself, and then check the answer that I now produce. Okay, so let's see how you've got on then. So to sketch, we've got transformations and we've got modulus all together here. So the first thing I'm going to plot is y equals x take away 4. So I know that when x is nothing, y will equal minus 4. When y is nothing, x will equal 4. So I know it goes through here. I'm just going to do it with a dotted line for the moment. Okay, I want the modulus of this line, so I'm sketching now the modulus of it. So what would the modulus look like? So the modulus will be everything that was negative, i.e. below the x-axis, is flipped on the x-axis. So this will stay the same and everything below the x-axis will be flipped. So I have now sketched y equals the modulus of x minus 4. Okay, and this will go through plus 4 here. Right, if I now multiply it by 3, that means I stretch it by a scale factor of 3 away from the x-axis. This will stay the same because that's nothing from the x-axis, and my 4 will now go to 12. So if I draw that in a different colour, so the whole thing is going to become a lot thinner, like this. Okay, so it's not to scale. Okay, so that's now 3, y equals 3 lots of the modulus. And now if I add 6, this black graph is all going to move up by 6. So if I get a new piece of paper, I'm going to plot that new graph now. So my 0.40 will now go to 46, it's moved up 6. And my 12 will now go to 18. So I'll still have this V shape and the whole graph has moved up 6. So I've now sketched my n of x, which was 3 lots of the modulus plus 6. Okay, now let's go back to the question. The question asked us to look at m of x equaling n of x. So this is n of x. Now my m of x is minus 2x plus k. So what does that look like? Well, let's imagine if k was 0, m of x will equal to minus 2x. So that's a line graph with a negative gradient going through the origin. So it will be like this. This will have gradient 3 and this will have gradient 2, so it won't be as steep. Okay, so this is y equals minus 2x. Now we're adding k to this to get our m of x. So if we add k, that means this orange graph is going to move up. It'll be parallel and it's going to move up. Now it's going to move up. Now we know it does not intersect my black graph because it has no real solutions. Now, so the cutoff point is here when it just clips the 0.46. So if we look at now, what would my value of k be? So it just clips here, okay? And then any value of k less than that will have no real roots. At this point, it has one real solution because it hits it once, and any value of k less than this value of k, it will have no real solutions because the orange graph and the black graph will not intersect. So this is my graph of m of x. So if I look at y equals negative 2x plus k, we know that the 0.46 is on this line, this point here. So I'm going to sub that into here. So when y is 6, x is 4. So this will give me a value of k. So 6 add 8 will equal k, which is 14. So my value of k is 14, so it will hit 14 here. Okay, so I've got this graph, y equals minus 2x plus 14. So any value of k less than 14, these two graphs will not intersect. So therefore, what are the possible values for the constant k? K has to be less than 14 is my answer. Okay, that's a tricky question. We're putting in sketching and then we're thinking around that sketching about what happens with no real roots. Okay, and then here's a harder question now. This is my last question for this video. Okay, this is question 8 and it has 4 parts and this is on page 52. So have that in front of you, please. Okay, so you have your sketch of h of x, but you do not have any coordinates on there. I'm sorry, I'm going to have to put a fan on. I hope it doesn't. It's still a very hot day today. And I just need that fan on to keep me cool. Okay, so it's asking to find the range of h of x. Now, to find the range, well, we know from the graph that the range will be we need to find this minimum position here, and the range is all my values of y above this minimum value because this carries on forever. So I need to answer this question, to find the range, we need to sketch this graph and find the minimum point. So how are we going to find the minimum point? Well, I'm going to go right back and go look back at this transformation here. Okay, h of x equals 2/3 modulus x minus 1. I'm going to sketch this. So the first thing I'm going to sketch, and it's getting the order of this sketching, it's important. I'm going to sketch y equals x minus 1 first. So x minus 1 will go through minus 1 and will go through 1. Dotted line. I want now the modulus of it all. So I want everything above the graph, and then I reflect everything beneath the x-axis. Now I want 2/3 of this. So if I'm looking at 2/3 of this, and then I'm going to stretch it by 2/3. I'm going to multiply my y values by 2/3. So I'm just going to cheat here. 1 times 2/3 is 2/3. So that point will change to 2/3. And now I want to take away 7. So that means my whole graph will go down by 7. So I'm going to do a new sketch for that. Okay, so it was at 2/3, it's going to go down by 7. So 2/3 take away 7, or 2/3 take away, what's that, 21 over 3, which is minus 19 over 3. So it will go down to here, minus 19 over 3, and the 1, 0, this point here, will go down to 1, negative 7. So my sketch is going to look like this. So my whole graph shifts down 7. Okay, so I've plotted h of x. This is my h of x. So now I've got my minimum point. And I suppose we could have done that another way by just saying, well, when this will be, h of x will be the smallest when this is all 0. When this is all 0, I get negative 7. And to get this bracket to be 0, x must be 1. That's another way I could have done it. So I get my minimum point of 1, negative 7. Right, so my range, let's go back to the question. My range will be all my values of h of x is greater than or equal to negative 7. So my range is h is greater than or equal to negative 7. Excuse the dots here. Okay, next question. B. Why does the inverse not exist? Now, the inverse functions only exists for 1-to-1 functions. Now, this is not a 1-to-1 function. This is a many-to-1 function because you've got two values, for example, here and here, which will go to the same value. Okay, so this is a many-to-1 function. Therefore, the inverse function does not exist because inverse functions only exist for 1-to-1 functions. Okay, next question. You're asked to find, to solve part C, when is h of x less than, so I'm just getting my question again, apologies for this. When is h of x less than minus 6? Okay, so let's just write that question out again. I want to solve this. I want to find all the values of x for which h of x is less than negative 6. So here is my sketch. Okay, just done that again. And well, negative 19 over 3 is here. Okay, and then 3 will go into 19 6 times, so this is the same as negative 6 1/3. So negative 6 is just slightly above here. Yep. I just wanted to work out, because was it between, whereabouts did it cross? So here, so let me just draw my line. Y equals negative 6. So when is h of x less than negative 6? Well, if I just do that in a different colour, it's all these values here. All these values of x, my h of x is smaller than negative 6, yeah? So let's find these 2 points of intersection, and then we can say, once we've got that, then all my values of x between these 2 points will give me h of x is less than negative 6. So I need to solve when this positive modulus is equal to negative 6 and when the negative modulus is equal to negative 6. So what I mean by that, this is the positive modulus is equal to negative 6. This is point A that I'm finding now. So if I solve that, I would have 2/3 x minus 1 equals 1. So 2x minus 1 would equal 3, equals 3 over 2. So x will equal 5 over 2. Now does that make sense from the graph? Yeah, x is positive. So here my value of x is 5 over 2. Okay, let's look at B now. So this is point B. So point B is my modulus part. This is my modulus is negative. The negative 7 stays the same and the negative 6 stays the same. So it's just this modulus that is now negative. So I'm going to solve this exactly the same way. So I'll get that to equal 1. X minus 1 will equal minus 3 over 2. So x will equal to negative 1/2 for point B. Does that make sense? Yeah, it's negative. You can see that from the graph. So my range of values for x, when h of x is less than negative 6, is x is between negative 1/2 and 5 over 2. So that is the solution. Okay, well done. Now we have one last tricky question, part B. State the range of values of k for which this equation has no solutions. Okay, so this is very similar to the first one that I did. So have a think about that. I'll give you a couple of clues and you're going to pause the video and have a go. So this is, you've got your h of x. You've already sketched h of x. You already know what that looks like. It's here with the minimum point 1 minus 7. And it's asking you, if I write down y equals 2/3 x plus k, it's asking you what's the range of values of k for which this line does not intersect this line. That's what it's asking you for. When does this line not intersect this line? What value of k? So pause the video and have a go at that. It's very similar to what I did with you in the first example. Okay, so let's see how you got on with that. So what I'm going to first of all do is sketch this line, y equals 2/3 x. Now the gradient of this line was 2/3 because you're told this is what h of x is. Yeah, so if I was to multiply that out, the coefficient of x is 2/3. So the gradient of this line is 2/3. The gradient of this line is 2/3. Okay, so if I were to sketch this line, I would have this, and it's going to be parallel to this line. So this is y equals just 2/3 x, and this line will be parallel to this line because this gradient is 2/3. Now, that you can see that's intersecting, so it has a solution here. It has one solution. It won't intersect here because these lines are parallel. So when will this line not intersect? When will the orange line not intersect the pink line? Well, if I went up this way, it's always going to intersect because this pink line goes on forever. But if I brought it down here, at this point, when this line coincides with this line, it has one point of intersection. Anything lower will have no values where they intersect, no points of intersection. So I'm going to move this line down to here and work out how far have I moved my equation down, i.e. what's the value of k now for this line? Well, we know this point is on the line. So when x is 1, y is -7. So if I put that into my equation, -7 is 2/3 times 1 plus k. I can now find my k. So k will be -7 and 2/3, or -23/3. So that's my value of k, and what values of k, that's the value of k when this line is the same as the pink line. So all my values of k less than -23/3 will give me no solutions. Okay, because as here it has one solution, it hits it at one point, then going down it won't intersect at all. Right, so that's the end of this video. We've gone through a couple of really tricky questions there, and what I would like you to do is set on show my homework, and it is also here. Okay, so do some lovely sketches again, and this is the end now of chapter 2. Well done. Thank you for listening.